Hey, welcome to part 2 of my Raspberry Pi LED tutorial. If you haven't watched part 1, go check it out now, otherwise you're going to be very lost. Okay, moving on. I'm going to wire up the yellow LED just underneath the red one here at row 21. And I'm going to place the green LED here beneath the yellow one at row 24. And like I said before, the row placement isn't all that important as long as your circuit can be completed. Feel free to experiment later once you've gotten everything working. Okay, now we need the resistors for our yellow LED and another resistor for the green one. Make sure you've lined up the 3 smaller bands toward the longer lead on the LED and the short lead is on the negative blue column. Now we need 2 more pieces of wire. So let's get a yellow wire for our yellow LED, and I'll take a green wire and use that for the green one. And let's plug it in here next to the yellow LED's resistor at row 28. And the green wire can go here on row 30. Now with the other end of our wires, we need to find another GPIO lead. For the yellow LED, I'm going to go here below number 4, which we're already using for the red LED. And it's in the spot labeled number 17. But on our breadboard, it's actually row 8. I know this can get confusing with all these numbers being thrown around, but just follow along with the where I'm placing them on the video and look at the diagram that I'll have in the description below. And for the green LED, I'm going to go up here below number 17 in GPIO number 22, which is on row 10 on our breadboard. Now that that's done, we should have everything set up in order to run our stoplight. And we've already imported everything that we would need, except for one more library we need to control some timing. So let's go ahead and do that. And if you have your Python interpreter still up, type in this, import time, and hit enter. Now we can use a sleep timer to control how long to wait in between turning our LEDs on and off. And in a normal stoplight, the light is green for a while to let cars pass. Then a yellow warning light for a shorter time period lets drivers know that the red light is coming soon. Then the red light comes on, signaling drivers to stop. So how can we do that with our LEDs? Well, we can write a short script that will loop through a few commands. But before we can do that, we need to set up our yellow and green LEDs in Python like we did for our red LEDs. So let's go ahead and do that now. Since our yellow LED is on GPIO number 17, we're going to type in gpio.setup, parentheses 17, comma, gpio.out, close parentheses. Now our yellow LED's I/O is ready to go. Our green LED is on GPIO number 22. So we do the same thing basically, but replace 17 with 22. So gpio.setup, open parentheses, 22, comma, gpio.out, close parentheses. And now our green LED is ready to go. And now we're ready to get started with our Python script. To perform a loop, we're just going to start a never-ending while loop. If you're familiar with programming, you've used while loops and for loops. So basically what we're going to do is this, while true. And basically what that says to Python is while true, which is always going to be true is true. I know that's kind of redundant, but it just says continue this loop as long as that condition exists, which it always will until we close it using Control-C. Then we need to turn our green LED on. Python is sensitive to spaces and tabs, so use a tab before typing the following lines of code. So tab, then type gpio.output, open parentheses, 22, comma, true, close parentheses. And remember, you can substitute 1 for true if you want to do that. Then we need to tell Python to wait for 5 seconds with time.sleep, parentheses 5, close parentheses. Now let's turn the green LED off. So gpio.output, parentheses, 22, comma, false or 0, close parentheses. Then we can repeat the process with the other two LEDs, except with yellow, we want a shorter time period to wait before turning it off and moving on to our red LED. So GPIO.output parentheses 17, comma, true or 1, close parentheses. Time.sleep parentheses 2, close parentheses. Then GPIO.output parentheses 17, comma, false, close parentheses. So here we're just waiting for 2 seconds. And lastly, we have the red LED. So we do GPIO output parentheses 4, comma, true, close parentheses. Time to sleep is going to be 5, so time dot sleep parentheses 5, close parentheses. Then to turn it off again, GPIO dot output parentheses 4, comma, false, close parentheses. So the red LED will turn on and after 5 seconds turn off. And since our script is in this never-ending while loop, when the red LED is turned off, it will go back to the green LED again at the beginning of our script. And to start the script, you can just hit enter on a blank line. And in order to stop the script, you type Control-C. I'll just let the script run through a few more times before stopping it. But while it's doing that, let's talk about what we're going to do next. Next, we're going to play around with some of the timings and also learn how to save our scripts to run them again later. Because to type all of this into the Python interpreter every time we wanted to run a script or change something would get rather tedious. So I'm going to show you how to run a Python script from a text file. We're going to use the Pico file editor and start a new file called rapidblink.py. So to do that, stop the script if you haven't done so already with Control-C, and then exit Python using Control-D, and then type pico space rapidblink.py. Now in this new blank rapidblink.py file, we can put all of the setup steps that we did earlier in case we want to run this after shutting down or closing Python. And if you've been following along since part 1 without stopping, you might get a couple of errors, but don't worry if you do, the script should still work just fine. I've inserted the GPIO.set warnings to false on line 2 in my script to silence those warnings. Okay, so here's what we're going to do in the RapidBlink script. Copy it just as you see it here. The spaces after the while true statement are tabs, and this is very important in Python as tabs and spaces do matter. I'll have a link to all of these commands in the description below so that you can copy and paste them if you want. So I'm going to leave the script on the screen for just a few moments. You should probably pause here if you're typing this in by hand. Okay, now that you have all the commands in the text file, let's save the file using Control-X, then just answer Y here for yes and hit enter to save. Now that we're back to the command prompt, let's run the script. So we will type Python space rapidblink.py. And by the way, you should still be root to do this. But if you get an error, make sure that you're root by typing sudo-i to put it into interactive mode so we don't have to type it every time we want to run something. You should now see your LEDs rapidly blinking back and forth. To exit this script, just do Control-C like we did before. Now, when this script was terminated using Control-C, chances are you probably have one of your LEDs stuck in the on position. So how do we turn that off? Well, you could go back into Python and type all the setup stuff in manually, or we could create our own script that turns all the LEDs off. So let's do that now. So we're going to create a new file called ledoff.py. So pico space ledoff.py. And here are the commands that you need to type in or cut and paste from the link I'll provide in the description below. Once you have all of that in your file, you can save it just like we did before using Control-X, answer Y for yes, and hit enter to save. Basically, what this script is going to do is set up our GPIO and then set all of those outputs to false. Now let's go back into Python and run it. So Python space ledoff.py, and you should see all of your LEDs are off at this point. And that's about it. Hopefully everything went well for you and you now have a functioning LED stoplight. From here, I would recommend playing around with different timings by making your own scripts and use the ones that we've made as a template to make your own. Play around with it, have fun with it. I hope you really enjoyed this tutorial. It was a lot of work, probably the most work I've done on one so far, but I had a great time making it. And be sure to subscribe, have fun with your Pi controlled LEDs, and as always, thank you for watching.